Hi folks, so today's video is polyesters and we're going to learn about what are they and how they're made. Apologies that the lighting's not great. I'm recording this in the evening in the dining room and there's a dimmer switch, and if I turn the dimmer switch on the phone goes all fuzzy and it can't really pick it up very well. It also causes a reflection on the tablets, on the whiteboard, so I'm going to do it in low light conditions. Again, apologies if I'm whispering a little bit, but I'm recording this and my daughter's room is directly above this room, so if I speak too loudly I'm going to end up waking her up. So to get on with it, so polyesters, what are they and how are they made? Before we go on to that, I would just like you, as always, to have a go at the quick quiz. So if you want to pause the video to have a go at these questions and then I'll go through the answers with you. So if you want to pause the video and I will go through the answers now. So just drop my rubber. Perfect start. What is a polymer? And if you didn't know any of these, most of these are from my previous few videos. So what is a polymer? Polymer is something that's a long chain. It's made of repeating units. Repeating units. Those repeating units are called monomers. I haven't left myself enough space to write that in. Monomers. Poly means many, like a polygon, many-sided shape. Mono means one, like a monocle or a monobrow. Right, and they have a high relative molecular mass because they're such huge long chains. Right, draw methanol. So two parts to this. First part, meth. So if you remember our trick before, meth, eth, prop, bute. 1 carbon, 2 carbons, 3 carbons, 4 carbons. So meth, 1 carbon. And then anol is the name, means it must be an alcohol, and alcohols have an OH. So I'm just going to rub out the rest so that we can see this. So we need 1 carbon because it's meth. We need to have an OH, and then so the rest has got to be H's because carbon's got to have 4 bonds. So it's got 1, 2, 3, 4 bonds. That OH could be anywhere. You could draw the OH up there, and then that one would just be a H, so that's fine. Right, draw ethanoic acid. So meth, eth. So it's eth, which means it's got 2 carbons, and oic acid, so it's a carboxylic acid. Remember, carboxylic acid is Cu, which is a carbon, double bond O, and then an OH. So we've got 2 carbons, because it's eth. One of them's got to have this, so it's double bond O, OH, and then we do the bonds. Carbon needs 4 bonds, 1, 2, 3, 4. So this one's done, and this one needs the H's on it. H, H, H. So that's ethanoic acid. What is this polymer called? And I've rubbed it out a little bit. Cl. So we know it's poly because it's a polymer. So it's poly something. And just in case I run out of space, just check that's still in shot. Right, so it's poly, it's going to be eth because there's 2 carbons in this repeating unit. So something eth, and it's ethene because they would have had a double bond, right, before it joined up to make a polymer, and it's got chlorine in it. So it's poly, chloro, I can't fit it in, but chloro, ethene. So that would be on one word, right? One line, polychloroethene. And then what polymer is used for non-stick pans? So that is PTFE, polytetrafluoroethene. Polytetrafluoroethene. It's in the previous video on polymers. Right, so going on to today's, rub that out before my wife sees. Right, polyesters, what are they and how are they made? So it's poly and then to do with esters. So before I tell you what a polyester is, I should probably tell you what an ester is. Now, weirdly, on the GCSE course, you don't need to know what an ester is. You just need to know polyesters. But I feel like I can't tell you what a polyester is without talking about what an ester is. So I'm going to draw this chemical first. Let's have double bond O, OH, H, H, H. So you should be able to name this if you want to have a go at naming it just before I tell you. So 5, 4, 3, 2, 1. So this is ethanoic acid. Eth, because there's 2 carbons, meth, eth, and that's carboxylic acid. And then I'm going to draw this over here. Right, if you want to have a go at naming this, okay, you should recognise that's methanol. It's 1 carbon and it's got an OH. You might wonder why I've drawn it as HO. Normally, I draw it this way around, right? I tend to, just out of habit, draw the OH there. What the OH actually means is there's a carbon bonded to an oxygen, bonded to a hydrogen, right? It's gone like that. So the carbon, the oxygen's bonded to the carbon. So it's carbon bonded to oxygen, bonded to hydrogen. You'll see why I need to draw it the other way in a second. So I'm just going to put the OH over here. And I'm writing it as HO because what that means is that the oxygen is still bonded to the carbon. So I've got methanol here, and then I've got ethanoic acid here, and then these react together. And what happens is we take away those, like that. And what can I make with that? Well, I've got an O, a H and a H. So what I make is H2O. H2O, I make water. And then if I rub that out, what that has left me with is that. And if you look, this oxygen needs to make a bond and this carbon needs to make a bond. So they join together. So if I just draw this one over here, so that would be O to C, H, H, H. Right, and then so this is an ester. You don't need to know for GCSE about, the esters are another homologous series like alkanes, alkenes, alcohols, carboxylic acids, and the functional group for an ester is that. So it's C double bonded to O, then an O, and then a C. It's that part. You don't need to know about those for GCSE, but that's what an ester is. And you make it by having a carboxylic acid, C double bond O, OH, you know, bonded to like whatever. That could be a H, could be a massive long molecule. We don't care, but we're just interested in that part. And then we've got the alcohol over here, C, H, H, and then bonded to whatever, you know, it could be a H, could be a long molecule, we don't care. And then we join them together by removing water. So I think I drew it the other way around earlier. I think I took OH out of there and H out of there. If you're doing A level, you need to be specific. I think I actually did it the wrong way around earlier. But it doesn't matter for GCSE, you just need to know that we are taking out 2 H's and an O, and it has the same end effect, because if I remove the 2 H's and an O, that makes me water. And then this needs a bond and that needs a bond, so they join together, and then that would be whatever that is. So that's our ester part. But Mr. Tinkler, I hear you cry, that's just an ester, and we're supposed to be learning about polyesters. So what are they and how are they made? So remember we said poly means many. So it's just lots of esters. I should add, by the way, this is made by a dehydration reaction. And the reason it's called a dehydration reaction is because like if you're dehydrated, you don't have enough water. This is dehydrated because we removed water from it. We took out H2O, so it's a dehydration reaction. So a polyester, lots of esters. And how you make those, and this looks unfortunately a little bit hideous when I draw them all out. We're going to start with a molecule, hopefully the orange is showing up. We're going to start with a molecule called a diol. I think that's showing through okay. Do you know what, just in case it's not, I'm going to switch to purple. We're going to start with a molecule called a diol. And a diol is like di for two, right? Like carbon dioxide. Carbon monoxide, mon for one, carbon dioxide, CO2. A diol is something with two, it's like a double alcohol, it's something with two OHs. So I'm going to start with a diol. So I've got C with an OH there and an OH there. So H. That is a diol. There's two alcohol groups on it. So if this was just a H, that is methanol, but it's a diol because I've got two OHs on it. And then I'm going to start with, over the other side, I'll do this one in black, a dicarboxylic acid. So again, di means two, so dicarboxylic acid. So I'll draw my two carbons, double bond O, OH, so that's one carboxylic acid, but then it's also got a carboxylic acid on the other end, OH. Okay, and so to make a polyester, you need two monomers. So instead of one repeating monomer, you have two monomers. And then what happens is we lose that bit there, which forms our water. So we get H2O up there. And then they want to join together, right? So that goes over there and joins on. I'll just draw it again over here. C, H, 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 O. Right. So that's what's happened first. But obviously we haven't just got two molecules of this. We've got loads of this kicking around. So we would have another molecule of this diol over here. OH, OH. And this is why it's important it's a diol, because then the same thing happens at this end, right? It loses OH and H, and then that joins on together. That wouldn't really be a super long bond like that. I'm just, do you know what? I'm just being lazy. I will draw that out. So then that's connected onto there. So the carbon, H, H. We've still got the OH there. So now this carboxylic acid has been joined at both ends. But obviously we've got more than one dicarboxylic acid. So we've got another carboxylic acid over here, OH, C, double bond O, C, double bond O, OH. And then this loses a water here, like that. And I am, to save you just watching me draw this out loads, I'm just going to connect that up. Right, and then obviously here, the carboxylic acid goes, we lose the OH, we lose the H from the carboxylic acid, and so we get O, C, C, right, double bond O, double bond O. And then this one, there's another one of the purple diols, so we lose the OH, we get O to C, H, H, and we're making a huge long chain. So to make a polyester, what are they? Massive, huge, long chains of esters. How are they made? You get a diol and a dicarboxylic acid, and then it's a dehydration reaction, dehydration polymerization. So it's not addition polymerization. Addition polymerization, just adding loads of monomers together. This is a dehydration polymerization because we are removing, every time you make a link, you're removing a molecule of water. So it's dehydration. And so we have a diol and a dicarboxylic acid, and then they all join together in alternating monomers. So we've got, and so the one that you need to know, I'll just do this for you again. The specific one you need to know, I didn't draw this one because, first of all, because it's a little bit longer. H, 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 H. So that's F, because there's 2 carbons, and it's a diol, and then we'll do a 2 carbon, let's do it a different colour, a 2 carbon carboxylic acid over here. Right, I'll show you how to draw the repeating unit of this. So what's going to happen is we're going to have one of these, then one of those, then a purple one, then a black one, black, purple, a huge long chain, right? Because we're losing that OH, sorry, yeah, we lose that OH, we lose that H, and then they join together, right? So when they join together, and I'm only drawing, you don't have to draw it in 2 different colours on the exam or anything, I'm just drawing it here so you can see like what started off where. H, 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 H. Obviously that H would be gone because it would join on to the next one. So you have a bond coming out there and a bond coming out there, and then this is where we do the brackets like our polymer, right? Because that would be our repeating unit. It would just repeat and repeat and repeat. So like this bond here would be joined onto, would be this bond to the next one in the chain with a little n, like the nth term in maths, because it repeats and repeats and repeats like n times. So that is our polyester, and this one is called ethyl ethanoate. Ethyl, because it was made from the diol, the purple bit was F, and then ethanoate because the carboxylic acid was F. I mean, it's not immediately clear because it's eth and eth in there, eth and eth. But if we'd used like if that was just a single carbon, so if it was like C, OH, OH, if that was the thing, then this would be called, you know, that wouldn't be there, and it would be called methyl ethanoate. Or if the dicarboxylic acid had another carbon in it, it would have 3 carbons, so it would be propanoate. So that, you know, it would be ethyl, if I stick another C in there, that would be ethyl, because the bit that's come from the diol was F, and then it would be propanoate, because the carboxylic acid part would have been the propanoate bit. But the only one that you need to know about is ethyl ethanoate. So what are they? Big repeating chains of that. How are they made? They are made as a dehydration polymerization from a diol and a dicarboxylic acid.